What's in a name? Everything. The power of a name has long been immortalized in prose, poetry, and history. It is your face to the world, your ambassador of quality that reflects your ideals and aspirations. Thompson's, a name, a family, a tradition of excellence. So it is with Thompson's Toyota, where our professional and courteous staff are eager to help you drive home your dream vehicle from the largest selection of new and used Toyota cars and trucks at the best prices. And if your vehicle needs service, our Toyota factory-trained and certified service technicians have the skill and expertise to do the job right and do it right the first time. Thompson's Toyota, where you'll always be treated like family.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Fried Planets, presented by Science at NASA. Astronomers have just caught a star in the act of devouring one of its planets. BD plus 48740, a red giant they observed using the 9.2-meter Hobby-Eberly telescope at the McDonald Observatory in Texas, appears to have the fumes of a scorched planet in its atmosphere. This is consistent with a rocky world recently destroyed. Could the same thing happen to Earth? Yes, indeed, says Alex Volchan, a member of the research team from Penn State University. A similar fate may await the inner planets in our solar system when the Sun becomes a red giant, some 5 billion years from now. Researchers who specialize in stellar evolution have long known that the inner planets are in danger. The trouble starts in the distant future, when the Sun's core runs out of hydrogen fuel for nuclear fusion. To keep the fires burning, the Sun will begin to fuse hydrogen outside the core, in a layer closer to the stellar surface. This will turn the Sun into a red giant, at least 200 times wider than it is today. Mercury, Venus, Earth, and possibly even Mars could be engulfed. The fate of Earth is not a certainty, however. Some researchers believe that Earth's orbit might spiral outward, keeping the planet at a safe distance from the approaching inferno. This could happen if solar winds carry away a significant fraction of the Sun's mass in the years leading up to the red giant phase. On the other hand, the Sun might expand so quickly that our planet has no chance to escape. Earth would get caught in the Sun's rapidly advancing atmosphere and spiral inward to oblivion. Observations of red giant BD plus 48740 lend credence to the second possibility. Our detailed spectroscopic analysis of BD plus 48740 reveals that the red giant contains an abnormally high amount of lithium, says Monika Adamoff, who led the study at Nicholas Copernicus University in Torun, Poland. Because lithium is easily destroyed in stars, finding lots of it in an old red giant is unexpected. The most likely source is a planet. Volchan explains, it is probable that the lithium production in BD plus 48740 was triggered by a mass the size of a planet that spiraled into the star and heated up while the star was digesting it. The team found another piece of evidence, too. BD plus 48740 has a gas giant planet 1.6 times bigger than Jupiter, which has not yet been devoured. The big planet has a highly elliptical orbit. In fact, it is the most elliptical orbit ever found for a planet around an older star. Its orbit, which almost surely started out circular, was probably altered by some catastrophic event, like its star having an inner planet for lunch. One day, he says, our own solar system may end up the same way. In 5 billion years, the fried planet could be Earth. Until then, for breaking science news, stay tuned to science.nasa.gov. Getting to know the Goldilocks planet, presented by Science at NASA. NASA's Kepler spacecraft is discovering a veritable avalanche of alien worlds. Recent finds include planets with double suns, massive super-Earths and hot Jupiters, and a miniature solar system. The variety of planets circling distant suns is as wonderful as it is surprising. As the numbers mount, it seems to be just a matter of time before Kepler finds what astronomers are really looking for: an Earth-like planet orbiting its star in the Goldilocks zone. That is, at just the right distance for liquid water and life. Kepler has already located a few Earth-sized planets, but they are too close for comfort to their parent stars. These recent finds have heightened the sense that a big discovery is just around the corner. I believe Kepler will find a Goldilocks planet within the next 2 years, says Sean Donegal-Goldman, a researcher at NASA headquarters who specializes in exoplanet biology. We'll be able to point at a specific star in the night sky and say, there it is, a planet that could support life. But finding a Goldilocks planet is just the first step. Getting to know it is much more difficult. The problem is that, in the cosmic scheme of things, Earth-sized planets are relatively small, and the ones Kepler is finding are staggeringly far away. Most are hundreds or even thousands of light years away from Earth. Almost completely hidden by the glare of their parent stars, these distant pinpricks are very difficult to study. Fortunately, NASA has a plan. The reflected light of an exoplanet tells its story, explains Kepler program scientist Doug Hudgens, also at NASA headquarters. To get at that story and learn about the planet's atmosphere and composition, we can use a technique called transit spectroscopy. The basic idea is simple. When a planet reflects the light of its parent star, the atmosphere of the planet leaves a subtle imprint on the reflection, a sort of spectral fingerprint that astronomers can study to learn what the planet's atmosphere is made of. One new mission under consideration by NASA, named FINESSE, is a fingerprint specialist. Short for Fast Infrared Exoplanet Spectroscopy Survey Explorer, FINESSE would measure the spectra of stars and their planets in 2 situations, once when the planet is in view, and again when the planet is hiding out behind its star. In this way, FINESSE can separate the planet's dim light from the stellar glare and reveal the fingerprint of the planet's atmosphere. NASA is also considering an observatory named TESS, the Transiting Exoplanet Survey Satellite. Supported in part by Google, the MIT-led mission is specifically designed to find exoplanets in the local galactic neighborhood. TESS would study hundreds of stars within 50 light-years of Earth, close enough to study in some detail. With better detectors and instruments designed to block the glare of parent stars, these next-generation telescopes could not only find a Goldilocks planet, but also tell us what its atmosphere is made of, what sort of cloud cover graces its skies, and maybe even what the surface is like, whether oceans cover part of the globe, how much land there is, and so on, says Hudgens. Donegal-Goldman expects big surprises. We found so many unexpected things about planets that now I expect to be amazed. When we can study a Goldilocks planet, I believe we'll discover something revolutionary about how life interacts with the planetary environment. Nature is so much more diverse than we anticipated. The possibilities, he says, are limitless. For more news about planets, both home and away, visit science.nasa.gov.
Here comes Solar Maximum, presented by Science at NASA. Only 93 million miles from Earth, a certain G-type star is beginning to act up. Every 11 years or so, the solar cycle brings a period of revved-up solar activity. Giant islands of magnetism, sunspots, break through the stellar surface in increasing numbers. Sometimes they erupt like 1 billion atomic bombs going off at once, producing intense flares of X-rays and UV radiation and hurling massive clouds of plasma toward Earth. This is happening right now. Only a few years ago, the Sun was in a state of deep quiet. But as 2012 unfolds, the pendulum is swinging. Strong flares are becoming commonplace as sunspots once again pepper the solar disk. Forecasters expect the cycle to peak in mid to late 2013. Fortunately, Earth is defended from solar storms by a strong global magnetic field. Researchers call it the magnetosphere, a bubble of magnetism that springs from the planet's core and extends at least 80,000 kilometers in all directions. In March 2012, those magnetic defenses were tested. At the very beginning of the month, a remarkable sunspot appeared on the Sun's eastern limb. AR 1429, as experts called it, was an angry-looking region almost as wide as the planet Jupiter. Almost as soon as it appeared, it began to erupt. During the period of March 2nd to March 15th, it rotated across the solar disk and fired off more than 50 flares. 3 were X-class flares, the most powerful kind. As the eruptions continued, Earth's magnetosphere was buffeted by coronal mass ejections, or CMEs. One of those clouds hit so hard, the magnetosphere was sharply compressed, leaving geosynchronous satellites on the outside looking in. For a while, the spacecraft were directly exposed to solar wind plasma. Charged particles propelled by the blasts swirled around Earth, producing the strongest radiation storm in almost a decade. Particles raining down on the upper atmosphere dumped enough energy in 3 days alone to power every residence in New York City for 2 years. Bright auroras circled the poles, and northern lights spilled across the Canadian border into the United States. It sounds dramatic, but when all was said and done, the defenses held. No harm done. More storms are likely as solar max approaches in 2013, and some of them could have potent consequences. Solar storms have been known to disable satellites, cause temporary radio blackouts and power outages, and interfere with GPS signals. Some laypeople worry that even worse things might happen, like the end of the world. These concerns are prompted in part by stories about the ancient Mayan calendar, which supposedly ends on December 21, 2012. In fact, the Mayan calendar doesn't really end in 2012, but that's another story. The key point is, solar flares cannot destroy the Earth. Our planet has been orbiting the Sun for about 4.5 billion years, weathering solar storms that entire time. Anyone older than the age of 11 has lived through at least 1 solar maximum, and most retirees have lived through 5 or 6. As powerful as solar flares are, our planet's defenses are equal to them. Solar Max is coming in 2013. Enjoy the show. For more news about solar activity and what it means to you, visit science.nasa.gov.